energy is used in different forms. What is primary, what is secondary, I am going to explain in subsequent slides. Primary and secondary. Per capita energy consumption is one of the indicators of standard of living of the people today. Higher the per capita consumption, we feel, so our standard of living is much higher. Compared to most of the advanced countries, India is still lagging. But still, that is one of the indicators. Over the period of time, over the last few decades, our position is also improving. Almost 99.9% of the villages are all electrified under different schemes of the government. So that way, India is also moving forward. Dependence on energy sources are increasing day by day. We are depending on energy. Without energy, no activity can be performed today. On the lighter side, I should say, if there is no electricity, probably in our house today, there will be no sambar or any ground matter will not be there. That is the situation today, even from the domestic front. So this speaks a lot about the criticality of the need of energy for our day-to-day life. And process need the energy in different forms. We have to convert it from some coal to electricity to heat. So like that, heat using for cooling, for different purposes, different types of energies are required. We are handling different energies in our activities, especially industrial activity. So that is the background of this. That is the background of this discussion. And also we have read a lot of materials have come out that fossil fuels are not going to be perennial. Probably certain surveys say another 50 years, certain surveys say 70 years, whatever it may be, either 50 or 70. Within few decades, these fossil fuels which we are highly dependent upon today is not going to be there. So we have to find some alternatives. That is the reason why need for sustainable sources of energies. Production of energy is associated with emissions again. Now, a lot of concern has been expressed all over the world about the environmental situation, how environment is getting polluted, how we can control. We have to leave this planet for the next generation. This type of approach is coming. To deal with them, additional energy is required. If you want to reduce emission and pollution in the atmosphere, again we have to spend some more energy to that effect. So these are all the few points. Industrial sector. Why we are talking about industrial sector today? See, major chunk of energy is used by the industry. So there is a scope for conservation. That is the idea. Probably, as I told you, all these villages are 99.9% of India is electrified, and efficient methods of handling and usage has a potential for sale. Even domestic front, even though it is less than industrial share, but there is ample scope in our domestic consumption also for saving the energy. So what should be the point of focus now? Yes, this is necessary. We have to save. So focus point is potential for conservation at user point. We have to focus on those aspects. What are all the possibilities we can reduce the energy consumption? When I say reduce energy consumption, cost being a variable factor, the energy in terms of quantity reduction per unit of product should be considered. We call it specific energy consumption. How many rupees in the bill we have reduced, not the consumption or increase, because cost varies every year, almost every quarter. So energy efficient operation is needed. These are all the focus points when you are thinking or talking or discussing on this energy conservation. For financial calculation, the cost of energy is also a factor you must consider. So with this, we are just seeing this. There are two varieties I already told you. Non-renewable, once we use it, it is going to be exhausted. This nuclear, oil, natural gas, coal, these are all going to completely stop one day. If not today, maybe after 50 years or 70 years, whatever it may be, they are not the perennial sources. Next is renewable sources. See, every year rain comes, water flows, we generate hydro. This is again a renewable, solar, wind, and energy from waste, biogas, agro waste, and things like that. So these are all the type of renewable energy. We can use it again and again we can use it, renewable. So coming to just briefly, I will run through this electricity generation by sources. This is in our country. See, majority, even today, majority portion is dependent on this, our thermal generation. One side we say it is not going to last, but we are highly dependent on that. Slowly, this type area, small hydros and wind power, wind and the solar, these percentages are slowly increasing day by day because of various incentives offered by the government. And one side, second side, electricity tariff is going up every year. So because of that, many people are looking for this type of energies. Now, India cumulative installed power. Here again, our majority, it is just to highlight it is not to give the statistics, but to ensure that you will appreciate the dependence on this type of coal, oil, natural gas, and things like that. See, gas, coal, put together, we have very large extent we are dependent on these things. How we can reduce the dependency on this? One is consuming less of this, and second one is going for the alternative sources. When I say consuming less and less, it is not by reducing the production, it is by improving the efficiency and stopping the wastages. So this part, this is only to highlight this portion. I'm not concerned about these figures. It may vary survey to survey. And see here, India's primary source is metric ton of oil equivalent. Primary energy consumption, 550. This is just a figure. It may be at some time scale it is given. It may vary, may be different. So what I want to tell you is industrial segment 56%. Here we have lot of scope. And again, MSME sector, we have some scope. We have some scope here. So energy saving potential industry has the highest 60%. As per Bureau of Energy Efficiency, they have published the industrial sector has highest energy saving potential by 2030. Now, power factor. This also I will explain. What is the advantage of better power factor? Power factor, ideally, I told one, whatever input is there, so much of exactly same amount of power is converted into mechanical power in case of motor. Even it remains same in other cases also. So it remains same. So what does it do? What are the advantages of power factor? Increase the system efficiency, reduces maximum demand. I will show some example in the subsequent slide. Reduced current, reduced IR, I into R, resistance into current. Reduce I squared R. I squared R is the heat loss. Whenever current flows through a conductor, current squared into resistance of the conductor is the heat generated. For that heat, you are spending some energy. When I say IR drop from the sending end to receiving end, when a current I is flowing, I into R is the resistance of the wire. So much drop will be there. Suppose sending end 230 volts. Current is flowing, some resistance of the wire. 230 minus IR will be the receiving end voltage. When the poor power factor is there, current is more. I will explain the next slides. Reduced switchgear rating. If the current is more, that is when the poor power factor is there, current is more. When the current is more, you have to provide larger switchgear size, larger wire area to carry that current. So you will have to spend more on these things. These are all the effects of poor power factor. So sample will be shown later, where you have to connect these capacitors also, installation of automatic power factor control panels. See, automatically you can't go on sensing every time manually and then include the capacitor. I assume that inclusion of capacitor is the solution for improving the power factor. I hope all of you know. See, when I say power factor, see, generally in the inductive load, our industry, most of the loads are inductive. Induction motors, solenoid coils, relay coils, induction furnace, except certain heating furnaces and things like that. If it is induction heating, induction furnace, then arc furnace, they are all inductive. In inductive loads, current lags the voltage. Current lags the voltage vectorially. All these are in vectorial terms. So vectorially it lags. So the angle between the voltage and current is called phi or angle, that is phi, if it is phi, cos of phi is the power factor. Imagine the current lags 90 degree. Cos of 90 is 0. I into V into cos phi. I current, V is the voltage, applied voltage, cos phi 90 degree 0, it is 0. There is no power can be transferred. There is no power. The entire power is consumed in the apparent power, in the as the reactive power used in the equipment itself. There is no output power. Suppose it is reducing. Cos 0, suppose voltage and current are in same phase. That means there is no angle difference. So if that is the case, cos 0 is 1, ideal case. So your effort is to bring this angle nearer to 0, nearer to 0. That is the idea. So this is the power factor. Cos of phi is, you just imagine, there is no provision to write and show. If the voltage is a horizontal line, current lags behind some angle, you resolve the current in x-axis. That becomes I cos phi. I cos phi. What is the power? I into V. I cos phi into V. So Vi cos phi is the power. If cos phi is more and more, that means angle is less and less, output is more and more. If phi is more and more tending to 90 degrees, then it will be nearing 0. There will be no power. Now coming to transformers. Even in the transformers, it's a stationary equipment. Comparatively, the efficiency is much large here. It goes up to 97%, 98%. So low loss transformers are available. The transformer design, depending on the flux density in which they are working, thickness of the stampings of the core, what type of wires they are using for the winding, depending on that, efficiency will be different and losses will be different. So the core losses may be constant. Even if you don't load the transformer, there will be core losses taking place. So if the core materials are not of good quality, there will be a continuous loss in the transformer, adding to the energy loss. So you must be careful, must ask for the details. Replacing the old transformer with the energy efficient transformer. Similar to motors, you must have a plan. Whenever you think of this, you please think that. If you have a voltage problem, okay, before that, locating the transformer nearer to the load center, it is very important, because as the wire or cable length increases, resistance increases, drop increases, voltage regulation effects. So for that purpose, ideal is to keep the transformer in the center of the load. But many places it is not possible. I know in the center of the hanger you can't place the transformer. But however, you must bear it in mind that how far you can make use of this particular concept. If the transformer can be, the cables what you are taking from the transformer, it must be as shorter as possible so that losses are reduced. That is the idea. Locate the transformers at nearer to the load center at their maximum efficiency point. See, generally distribution transformers, all these transformers, distribution transformers, because you are not switching off. Power transformers are in power system, in receiving station, large receiving stations, generating stations and all. In distribution transformers, generally their highest efficiency takes place at around 70%. Even roadside distribution transformers, they are designed for much higher load to have the highest efficiency. Because when the load changes, they cannot be switched off anyway. All the 24 hours they have to be in service. Sometimes there will be loads as low as 20-25% in the night when all go asleep, then there is no activity. And sometimes there will be 70-80%, 90%. So the design the transformers in such a way, the efficiency will be somewhere around 40-60% load, 70% load, around that. If you operate at that load, it will be highly efficient. Similarly, when you are seeking for a transformer for your industry, at what load it should operate, what is the efficiency of that transformer, please have a discussion with the supplier. It will give a lot of, suppose some 10% increase in efficiency. If the transformer is designed to operate at, normally industry load will work at higher loads, higher loads. At that particular percentage load, your transformer should give a better efficiency. That point you must make with the supplier. For fluctuating load conditions, multiple transformers in parallel to share the load. See, there are maybe pressers and many there are fluctuation, forges and such places, fluctuating loads, impact loads, such loads. Better you have segregate them, have a different transformer. Instead of having 500 kVA one, have 250 kVA two, 300, 200 two, like that. Anyway, depending on the situation, you can do that so that the effect of these loads will not be felt by the transformer. See here, with VFD and without VFD, what is going to be the change? Compressor with VFD, compressor without VFD. See, where is 94% of this energy? Where is 59%? VFD reduces, if it reduces motor speed to lower the flow and match the actual air demand, resulting in the lower power consumption. Whereas a fixed speed machine would be running only at fixed speed, would unload in the same condition, resulting in higher energy consumption. See here, this is the clear indication. So nowadays, without VFDs, pumps or compressors, we should never go for. That is the idea. The whole thing, whole concept is shown here. The solar electricity can be used in standalone mode. That means for one installation, you have a solar plant installed, it supplies to that in this one. That is a standalone mode. You are not connected to the grid system. You are not working along with the grid system. You are independent. Another one is net metering or paralleling with the grid. You have a grid supply also. During night time, if you want, you can draw the energy from the grid. Parallelly, in the daytime, whenever the sunshine is there, the solar cells generate energy and you are using it. If there is any shortfall this way or that way, it is adjusted. Absolutely no problem. This is called net metering. Your energy is flowing to the grid when there is no load in your place. Whenever you have the load, your energy is used here. You are not importing any energy from the grid. So when you have excess, you are exporting. The difference is only charged as per the tariff applicable. So here, see, suppose this is the grid side, this is the grid side, and this is the solar panels. So there is an inverter. In case of grid, with this meter, how much energy is coming this way, how much energy is flowing to this, the net metering. Difference is shown here. If you have drawn more, to that extent you have to pay. If you have sent anything here, either they will pay or it will be in your credit. It can be adjusted in any further months, no problem. Converts the direct current DC to alternating current. Sometimes you require this inverter. Inverter is required. Because it is AC. But you don't have batteries here, because since you have working along with the grid, you are generating DC, converting it to AC, connecting it to the grid. So this is that extent. Without inverter, this is DC. You will not be able to connect it to this. So that is one point. Inverter converts direct current to alternating current. And here, then you can connect it to this. This is the method used. This is economical and useful also.
Now, how to think about saving energy in the facilities? That is something we have. We talk about these 7 types of losses of energy. This is a very what you can say good slide to start thinking energy efficiency. So with these losses in mind, how we can reduce these losses, it gives us an insight how we can save the energy. So the first type of loss we talk about is loss due to useless consumption. Now what this useless consumption means is that there is some non-productive period and the machines are on. Some maintenance is there, some setting is going on something, and the whole machines power packs are on, some utilities on, something is on when it is not required. The simplest example, there is a toilet and there is no occupancy in that and there is a light going on. So this is a type which is called as a useless consumption. So every attempt should be made to automate. When it is non-productive, things should stop. So it may not be possible each and every place, but attempt should be in that direction. Second is loss due to overconsumption. The set points are too high, or it's somewhat inappropriate usage, like a furnace temperature. You are melting some aluminum, let us say, and you want 715 degrees. for melting. I'm just giving an example. And you have set the temperature at 800 degrees. So that 715 to 800, what is the thing? That is excess set point being too high. Now, okay, 715 you require, you set it something higher because you need to carry the metal, molten metal. That is understandable, maybe 730 or something. But many times it so happens that it is 800. So this is just an example. There may be other things like compressed air set pressure being too high, chiller set temperature being too low. So many examples are there. So these are basically losses due to overconsumption. Third is loss due to non-optimization. So the equipment is not working at its design condition. The simplest example is a pump. A very oversized pump is there, then you're throttling it here and there and getting the flow that you want. So, if the pump is properly sized for the application, it will work the most efficient way. So that is something that we need to look at is key loss due to non-optimization we should consider. So all these points, as I said, they are to set a thinking process where you go in your plants and you kind of try to visualize where are my areas of non-optimization, where are my areas of overconsumption, where are my areas of useless consumption, and then we can do some what you can say analysis about whether there is a point in doing some energy saving project which you have identified, so to say. Then there is a loss due to not using recoverable energy. There are so many places there is waste heat available where it can help to save some energy. Next, type 5 loss, we talk about transmission losses like leakages, insulation loss. These things are also a major loss in the industry. Then transformation losses, which we talk about the last application. Like your electricity has come to the last application, like a lamp or a pump or whatever, furnace, whatever. And it is converted to some other form, like a light will convert the electrical power to the light energy. The pump will convert the electrical power to the mechanical power first and then hydraulic power after that. So it is moving some fluid. So this transformation from electrical, mechanical to hydraulic, for example, for a pump, this should be with the most efficient equipment available. So the idea is that go for most energy efficient equipment while purchasing, and when you are going for any replacement, please consider energy efficiency before doing that. And finally, there is a type 7, which is the renewable energy. Whatever we can use to renewable energy sources, that we should try and use. Next important aspect with every industry and even in ISO 50001, like the previous presentation was showing, there is a need for benchmarking. So benchmarking is a very important step of the energy conservation process. So when we talk of benchmarking, we say ki, against similar type of industry, what is our industry's specific energy consumption, which means energy per unit output. So in a cement plant, probably it would be kWh per ton of cement production. In a textile plant, it may be kWh per kg yarn. If you talk of a foundry, it may be kWh per ton of molten metal or kWh per ton of casting produced. Whatever is working for you in your industry, it's okay. So even in hotel, if you talk about kWh per occupied room is a benchmark which can be made. So each industry should have a very specific benchmark for its own product, and that gives us some insight into the energy cost towards the product also. So it is dependent on lot of parameters, so it may not be like to like, but there is always a possibility of comparison with similar industries. So that is something that each industry should have a benchmarking. And if you are not able to compare with other industries of your similar type, then you can compare against your own past performance. So this is important this way or that way to measure the specific energy consumption. Now talking of what you can say as individual equipment benchmarks, like if you talk of a chiller, kilowatt per TR, if you talk of a boiler, what is the percentage efficiency or steam to fuel ratio, or if you talk of compressor, what is the kilowatt per CFM. All these are benchmarks for individual equipments now. Now, plant level is one benchmark, and individual loads or individual utilities is one more benchmark. So, both these help us to see whether our energy performance is going okay or not.